Imagine waking up to not just one, but 8 sunrises and sunsets, seeing the moon bobbing in the center of the sky, and living on mountains that line the inner edge of a toroidal Earth. Welcome to the donut-shaped Earth, a fascinatingly surreal world where topography, climate, and even gravity defy everything we know today. Though planets naturally don't form in a toroidal shape, the laws of physics do theoretically allow such worlds to exist. A donut Earth would experience unique gravitational conditions. Depending on where you are, you could experience up to 3 times less gravity, like you're walking on the surface of Mars. At the poles, surface gravity would be 0.65 g, and at the equator, a mere 0.3 g. This low gravity would constantly try to collapse the planet into a sphere. To counteract this, a donut Earth would need to spin much faster than our current Earth, resulting in days that last only 2 hours and 50 minutes. The fast rotation and multiple day-night cycles would force you to adapt to working shifts and sleeping during periods of daylight. Animals dependent on lunar cycles for breeding and migration would face even greater disruptions. Speaking of the moon, it might settle in the middle of the hole or take on a figure-8 orbit around the donut Earth, leading to unpredictable tides and possibly making coastal cities uninhabitable. The climate would be similar to our current Earth, but with more extreme weather patterns. Frigid poles and warm equators would persist, but the interior mountains, possibly larger than any we know today, would add another layer of complexity to life on this planet. Predicting countries is tough, but civilizations would likely evolve in isolation due to the challenging geography. Despite these conditions, life would not only exist, but might even thrive. With separate evolutions on different continents, mass extinctions might be avoided. Imagine, the very concept of a donut as food might never have been discovered, yet inhabitants could well be pondering what a ball-shaped Earth would be like. It's a world of dramatic extremes, but, in many ways, still as habitable and dynamic as our round Earth.